and I'll need to be able to hear you all the way back there in the camera hear you as well. And then we also have a clicker. Clickers forward and back. It has a laser pointer. Do not use that for any bad purposes. Don't throw it at anybody, but if you want to point something out on the slide, you can do that as well. So who is going to have the, all right. Yeah. Now, last thing, if your group is the next in line to present, so human therapeutic funding, you guys are next in line to present, you can step out and kind of walk down the hallway if you would, if you want to talk about your presentation. You can step out during the prior presentation to have a couple of minutes to just kind of get your game head on. So if you guys want to step out and do that, you're welcome to do that. And then when they come up for the grant presentation, you guys can step out. So, well, they're going to have to make their best guess on that. So, they'll get a recap. Everybody's going to get a recap at the end. So, yeah, that's it. All right.
The recap is important.
Yes, the recap will be important. We'll do just like a real quick little good. Everybody can kind of put their heads together for an elevator speech. Does that, are we getting enough light here? Is that everything we can go with the camera? Okay. All right. I think we're about to get ready then. Again, during each of these presentations, we're going to ask that you give your full attention and appreciation. We'll have a couple minutes for questions from listeners at the end of each presentation.
I'm going to give you this gesture when you're 8 minutes, so you know.
Okay. We have too much issue with that. I came in right, so hopefully we're in the same place here. But all right, I think we're ready to get going. So please give a warm welcome to the genetic modification.
Morning. I'm Noah. This is Layla, Timothy, Eric, Harvey, and we will be presenting the future of genetically modified agriculture. Basically, our proposal is to host a scientific summit to address the issue of misinformation among the general public. We will be using our grant money to pay travel expenses for people who attend the summit, and we will be holding it in Switzerland. Before we get too far into that, I want to discuss the history of genetic modified agriculture. Genetic modification of biofuels has been occurring for about as long as humans have been born. Many of the crops we consider normal today, such as corn and wheat, were artificially selected by human beings to produce larger fruits or more seeds. The modern genetic engineering did not develop until the late 1970s, when these two men, Herbert Boyd and Stanley Cohen, developed the first transgenic organism in Stanford University, California. The general public immediately realized the potential uses of this technology and fought against it. The scientists held a temporary ban on all genetic modification research around the world, so they could meet at the 1975 Silmar Conference to create a set of ethics and safety guidelines for the future of research. In 2016, the USDA estimated that 90% of all corn, soybeans, and cotton grown in the United States were genetically modified. The majority of these were genetically modified to include either herbicide tolerance or natural pesticides. These have been proven to be safe for human consumption and increase crop yield. Someday, genetic modification will be the thing that ends war.
Much of the action being taken in the name of genetically modified organisms has come from concerned citizens. The FDA, USDA, and EPA have set legislation for genetically modified agriculture. However, many citizens believe that this legislation is taken very loosely. There are 176 types of genetically modified organisms, and citizens today have organized many movements and taken many actions to make these legislations stricter. For example, the Right to Know movement advocates for further experimentation and for further public knowledge on genetically modified agriculture. The Just Label It movement has also put legislators in place in order to advocate for more strictness on labeling of genetically modified organisms and for more information put on these labels.
there are two major problems that come along with GMOs. First is that there's a lack of knowledge on the subject. In a study done at a major university, around 53% of people asked did not do little to nothing about GMOs, and 1 in 4 people did not know what GMOs were. This shows that there is a lack of proper education at schools, or there's a lack of education at all. Secondly, there is very loose legislation on the topic. In a study done from Greenpeace, around 93% of corn grown in China was being illegally grown as a GMO. As of 2015, there was a new legislation that made the growth of GMOs illegal for 5 years. So how can we fix this issue? We can solve it by, we propose to solve it by doing a scientific summit and bringing all the best scientists from around the world together to gather information and put it out to the public. This information can be used to make new curriculums in schools and legislation for the public.
To fight this insufficient knowledge of GMOs, we plan to the scientific summit, where our goal is to release factual knowledge to the public around the world. This is important because GMO use needs acceptance. Without acceptance from the population, GMO use cannot expand and grow and help us. And our plan is more feasible because it will have worldwide publicity, and it will be held by top GMO scientists, and this will affect many people and reach many people.
So the logistics essentially covers the coordination of an event, the people, the facilities, and the supplies. So to kind of break it down, the event, like we said, is going to be a scientific summit. This is just so that scientists can come together, share their ideas, and collaborate, and then we would put it out to the public. We would call it the Berg Summit in honor of Paul Berg, the leader of the Asilomar Conference. The people, we would have 30 to 50 of the world's best GMO agriculture scientists from around the world come together. Facilities, that right there is the UN headquarters in Geneva, Switzerland. We would have it there because Geneva is a very hospitable city. They don't claim to have any sister cities around the world. They say that every city around the world is their sister city. So when scientists from around the world would come there, they would be very welcoming with open arms. And not only that, but Geneva is a central location in Central Europe. So it's a very good place to have everybody go to. And then finally, the supplies. There are no real tangible supplies that we would need, but for our group said that we would take a look at the financial side. So the airfare, the lodging, and the food cost. We decided that it would be about $3,000 to $5,000 per person, and with 30 to 50 people, if we had exactly 50 scientists and it cost the maximum amount, $5,000, that would be exactly $250,000, which is what the grant was. So that's kind of the logistics and how this would happen.
To combat the growing misinformation surrounding GMOs, we need to have a scientific summit that educators and scientists alike meet to find new ways to release all the information they have to the public. They need the educators because scientists aren't all that good at sharing information. So once we are through with the summit, people will be more willing to accept GMOs. So research will accelerate, and scientists will be able to create edible vaccines, more crops with higher nutritional value, such as golden rice, and someday may even solve the global hunger crisis.
If I were going to give you my money, where do you see the education coming 5 years, 10 years out? So you brought all these people together. What would you like to see unfold when they go back to their country? Are you specifically targeting like high school education or higher education? What
we want everybody, like the whole general public, to understand what it means for something to be genetically modified. But it would be good to start with high school age or children who are still in school, because they still have their whole lives, but they still have a chance to impact the future. So it's important for them to understand.
Are you, I'm going to ask, are you going to be neutral on this situation, or are you just wanting to have information about GMOs put out there? I'm assuming from what I've heard you propose to me, that my money's going to go to you to just kind of say, this is what a GMO is, done, and not support or decline it. Am I correct in that assumption?
Yeah. We're not going to take this out. We just want information.
You just want the information put out there. I'll ask one more question. I'm not trying to put you on the spot. I'm just asking you to give me an honest answer. When you mentioned Greenpeace making the statement about having 52%, I think I'm right in the numbers, about 50% of the corn grown in China at one point. Do you think that is a bias, data?
Well, yes, it could potentially be because they are it's an article, so they are going to have biased information. But at the scientific summit, that is why we're bringing multiple scientists, so that we can have both sides of it to create an equal kind of statute for it.
So you're going to remain neutral for the most part?
Yes.
Thank you.
So as more GMOs come out, will you hold more meetings, or is it just this one meeting?
We would like to have the information out, so if more information or more research is done on GMOs, the general public could work together instead of just the scientists meeting. So we could work together all as a general public to solve the issue if there is.
Okay.
Very good. Thank you.
So great question, and I'm going to tag off that. So say the summit is successful, that the information is put out there. How do you see that, sort of that next step about evaluating whether or not the public is actually getting that accurate information in an unbiased kind of way? Talk about that at all?
So to actually know if the information is getting out there and if it's getting out there correctly, I need to see how many news stations are releasing this information in a language that people understand. So they will, because scientists are kind of complex in the way they speak. So to release this information in a knowledge that I understand, and to see how many articles are actually publishing, how many scholarly articles are publishing, or information to scientists.
Okay, guys, you haven't done it yet. You need to talk about the previous presentation and just make sure you've done that evaluation piece as a group.
Are we supposed to be recording it?
Yeah, and you're only doing one. You got 4 copies, because that's the number of groups that are going to be up. So you're only doing just filling up one of the sections. Your entire group is still up.
All right.
Ladies and gentlemen, bring it up front again, and we're gonna have a little bit of break time after about, a little bit of break time, so if you need to go back and check the different presentations, stuff like that, you'll have that opportunity as well. So, at this point, please welcome the Human Therapeutic Clinical Group.
Good morning. My name is Cole, and this is Casey, Connor, Sage, Jason, and Pat. We're the Human Therapeutic Clinic.
Okay, so our proposal is we're requesting $300,000 to be able to conduct research at the University of Southern California on the replacement of somatic cells affected by Parkinson's disease using therapeutic cloning and stem cells. Why are we doing this? Well, in the U.S. alone, 1.5 million people are affected by Parkinson's, and additionally, 60,000 people are diagnosed every year. Furthermore, 23,000 people die from Parkinson's every year. And we hope that our research can dramatically decrease the fatality rate of Parkinson's. Now, what makes this important in biotechnology today? Well, we hope that through our research, we can boost scientists' knowledge and understanding of stem cells and help them find out what makes them special and what makes them them. And we hope that through our research with Parkinson's, that we will be able to find better treatments and maybe even a cure for other diseases such as Alzheimer's, diabetes, and cancer.
Okay, so human therapeutic cloning can be very beneficial to patients with Parkinson's. During our period of research, we hope to be able to find a way to replace the cells affected by Parkinson's with new, healthy ones. Now, many people are confused between therapeutic cloning and reproductive cloning. They think it's the same. However, it's not. Reproductive cloning is the making of an exact living copy of an organism. But therapeutic cloning uses a patient's cells to make new ones so that that patient can. In addition to the lack of public knowledge, there are government programs that exist to help these patients. Now, these programs are very expensive and not many patients can afford them. However, our research hopes to change.
The main controversial issues in relation to human therapeutic cloning are the ethical ones. Human therapeutic cloning originally required the use of female egg cells or umbilical cord cells to be able to fulfill its purpose. SCNT is called the somatic cell nucleus transfer, which is where an egg cell is taken and immobilized and its nucleus is removed and replaced with the nucleus of a somatic cell or body cell. This is then used. Electric shocks are then given to the cell to be able to create new copies of that original somatic cell. But recently, in 2007, Yamaka Labs introduced the idea of taking somatic cells and inducing them to be pluripotent cells or stem cells, which eliminates the need for human egg cells as well as umbilical cord cells. This is taken by introducing different genes and chemicals to be able to reverse the somatic cell's nature back to a pluripotent state. Our plan is to use induced pluripotent cells to be able to find a cure for Parkinson's disease and benefit the people afflicted by it.
Some of the actions that we'll be taking is to share a laboratory with the University of Southern California. And in doing this, we'll be using lab rats that will be afflicted by Parkinson's disease. We'll be using our procedures that we'll be researching in order to see how effective our cure is. And also, because we'll be sharing with the University of Southern California, we'll incur reduced costs. Another benefit of this is that we have already made breakthroughs with stem cell research, and especially with Parkinson's disease. Also, this is important as many lives are affected by Parkinson's disease. It will greatly benefit the public and medical research to further breakthroughs in doing such research to completely understand the interaction between induced pluripotent stem cells and Parkinson's disease.
Okay, so we're going to carry out this plan through us as a team of researchers and interns that we will obtain through the University of Southern California as they will be students. We're going to obtain a lab from the University of Southern California at no cost, where they help for 4 years because they have given us labs to use for free. The estimated cost is actually $300,000. This was changed since we had extra costs due to research. We will know how we impact in the future through the number of successful experiments that we have, and through that we will know if we can help people with Parkinson's. And if we do have some cure for it, and we'll use in the outside world, we'll see how people are affected by that. We will obtain the other $50,000 we need through the National Science Foundation.
In conclusion, with human therapeutic cloning is a powerful technology that can be used to treat degenerative diseases like Parkinson's disease. With this grant, we can conduct extensive research to finding a treatment for Parkinson's disease therapeutic cloning. Thank you. Any questions?
We got one from the audience, yeah.
Okay, one of your pictures said 1.5 million people were affected by Parkinson's, but how many people actually have it?
1.5 million, because they're the ones who are affected in terms of they have this.
Okay, I thought you might have meant like secondary people, like family members would count as affected or something.
Can I get a little more clarification? Because you started off and it seemed like you were doing embryo versus therapeutics. Are you trying to get funding and telling people that we should therapeutic? I kind of lost focus on where you were going on that. You said that two hot topics.
So human therapeutic cloning is the use of stem cells to be able to create new cells for like patient use. Like often it's like injected into people, which also induces like the healing of cells that are already affected. And so we're funding the research of induced pluripotent stem cells, which are an alternative to embryo cells.
So Parkinson's is your example, not that you were trying to focus on that for Parkinson's.
I have a clarification need for your funding. Are you paying rent at USC for the labs, or are you getting that funding, or that you're not paying rent?
Oh.
There was a little confusion with what you were saying and what was.
We're not paying rent, they're offering labs
charge for the rent. And how long what's your estimated time frame for research? 4 years? And that's with lab rat, correct? And then from there, what's your plan?
The plan was then to, if we had, the results that we expect to have with a treatment, to then create an experimental years at a hospital near, the University of Southern California. And if it doesn't go in that direction, we plan to switch our focus aspect.
Did you do a projection of idea of where that funding might come from?
We do not.
Just real quick, did you research any other similar research that's going on right now, either in Parkinson's or another type of disease?
Yes, so I had, at least on my research, some information of ALS, which is also another degenerative disease, but that's more muscular instead of neurological, as well as spinal cord injuries with the same kind of like electrical.
And I'll clarify my question. Any other similar research that's using the pluripotent cells?
Thank you very much. One tip to always remember before your public presentation. Smile. Smile because. Why do we smile? Because your body thinks you're happy. Right? There's that. So why do we breathe? All right. Bring it back to the front, please. Please welcome the drug xenotransplantation group.
Hello, everyone. I'm Eli.
I'm Kate.
I'm Miles.
I'm Shanae. I'm Colleen.
For our project, we have xenotransplantation and the use of immunosuppressant drugs. Xenotransplantation, process of taking a non-human organ, putting it into a human. And immunosuppressant drugs are drugs that basically suppress the immune system to allow the organ to thrive inside the body that it is going into. This process of xenotransplantation was first attempted in the early 1900s, but failed due to the fact that the immune system rejected the organ. To help the immune system basically accept this organ, we propose to try to make a strong enough immunosuppressant drug to allow the new organ to thrive in the body. This is a very important topic to us because there is a shortage of human organs to be transplanted based on how many people are on the waiting list to receive an organ. We're able to perfect this process of xenotransplantation. It can ultimately save thousands of lives.
The action of putting animal organs into humans is, of course, surrounded by some controversy. Immunosuppressant drugs are used following an organ transplantation to weaken the immune system so the body will accept the organ. When using animal organs, you open the door to cross-species infection. This is due to the fact that humans often lack immunity to infections that originate in animal populations, such as swine flu. This, however, does not need to be as great of a concern as companies such as Revivifur are inserting human genes to pigs' hearts, livers, and kidneys. This will reduce the risk of infection and rejection. A second point of controversy is the ethics behind this. Some people believe for religious and personal reasons that it is wrong. To ensure that no boundaries are crossed, the decision to use animal organs will be left to the patient. A final point of controversy is whether or not this should be considered animal cruelty. Animal rights activists question whether or not animals should be euthanized and have their organs used for humans. Animals whose organs are used in these life-saving procedures euthanize and put to rest quickly and peacefully. Their deaths will not go to waste, as their organs will save the lives of many men, women, and children across the world. Currently, drugs such as Myfortic are used following an organ transplant. While such drugs have shown success, they do not always do their job. National Kidney Foundation reports that 17% of kidney transplant patients lose their kidney within the first couple years, and 20% of kidney transplants are retransplanted, meaning that the organs were rejected or infected. This means that we need to look for a better solution. We need to look further to find something else that works.
So what are some of the current issues in regards to xenotransplantation? There are currently over 100,000 people on the waiting list to receive it. Out of those 100,000 people, an average of 22 people die every day waiting to receive an organ. Why does this issue need more attention? This issue needs more attention because the amount of deaths caused by waiting for an organ and rejected organs is far too high for the medical advancements in technology we have today. Some of the actions that can help with these issues is using human-grown organs inside of pigs doing this, we will lower the number of patients on the waiting list and lower the death rate at the same time. We'll also try to create, we will also be creating a new immunosuppressant drug, which will help reduce the risk of rejection.
So the action that we would like to propose is to establish a time-sensitive research project at a local university, develop an immunosuppressant drug that will allow organs from animals to survive in humans for longer periods of time. This is important because thousands of people die every year because they don't have organs. The organ shortage is so great, and we believe that if we are able to create an immunosuppressant drug, that within a few years, thousands more people won't have to wait to receive an organ, and that the immunosuppressant drugs used on any type of organ that needs to be transplanted.
In order to achieve our goals, we will hire a part-time researcher and rent out a lab at the University of Virginia for a time span of 5 years, from 2018 to 2023. During this time, our researcher will work to develop an immunosuppressant drug that will better work for xenotransplantation. Once this drug is in a testable state, we will then get animals and use their organs to test out if the drug works on humans. Overall, this will cost $328,900. However, this grant will only be funding our research portion of this project. And this cost does not include our surgical costs, as those will be done by another team. Further funding will come from government organizations or private associations, such as National Institutes of Health or the American Society of Transplant Surgeons. We will determine if this drug is successful by seeing how well it does in humans. If there are unintended side effects or it's not as successful as we hoped it would be, then we will take it back in for further refinement and testing. We hope to have this project complete by 2025.
As you can see, finding an animal whose organs are compatible with the human body and researching an immunosuppressant drug that will sustain these organs is highly important, as it will help to lessen the gap between available organs for transplantation and the organs that are needed for transplantation. The controversies behind xenotransplantation should not stop us from establishing a time-sensitive research project. We will go into developing new immunosuppressant drugs.
Do you plan on for the people who get the transplants, would they have to keep taking the immunosuppressant drugs, and would that lead them to be susceptible to other diseases that could then end their lives? Or do you plan on weaning them off of the immunosuppressant drugs and hoping the body doesn't reject the organ?
I suppose it depends how the immunosuppressant drugs work out. Obviously, we have not developed immunosuppressant drugs now. You're asking for the money to develop immunosuppressant drugs, so it really depends on how the immunosuppressant drugs affect the human body.
Have you researched where you will get the animals that you would use the organs from?
Yes. So the animals that will be used will most likely be pigs, due to the fact that their organs are the same size and shape as humans, more or less. And so the pigs will be gotten from local farms.
Will those have the human genes that you were mentioning before?
Yes. The company that I mentioned before, Revivaform, it is actually based in Oxford, Virginia. So they have been adding in 5 human genes to the hearts, livers, and kidneys.
So theoretically, once you develop an immunosuppressant drug, if it works on humans the way you want it to, wouldn't weakening the immune system leave the individual susceptible to more infections of other types?
That's likely to happen with any immunosuppressant drug, just because the idea is that it is the immune system. So I suppose that the person would, their immune system would be weakened,
different, like when a human dies, they donate their organ, and when you would have to do all that stuff to the pig, it's a cost money to raise the pig and all that stuff, and then donate it. How much of that different cost?
To raise the pig for about a month, or to raise 10 pigs for.
Oh, I'm not even close enough to the mic. I'm sorry. To raise about 10 pigs for a month, it takes about $2,800, and that's the amount of time that we want to hold them.
I have to stand up. Okay, so you're using pigs, right? I know there's some organs in pigs that can't be transplanted in humans, such as their arteries. How would you combat that?
It's really simple. We would just find another animal that's more compatible and use that one.
One more.
Okay, how would you deal with a lot of the animal cruelty complaints? Because I know keto, as soon as you would start trying to test on bigger animals other than rats, would have some major issues with just killing animals simply for their organs. Would you do something else with the meat once the animal was euthanized? And in a case with the euthanized animal have issues with the thing used to euthanize it, such as the shot.
So I suppose that there are other ways to kill the animal, but I think that euthanasia would be the most humane way. That's how it would be done, which is of course quickly and peacefully. Their deaths, I mean, it would go to waste. Their organs would be used for research, or they would go directly into somebody to save their life. So, I mean, it's unfortunate that the animals have to die, but they die.
Good questions. Nicely done. Thank you. Hey, we're going to do gene therapy. Y'all stay in for this presentation rather than going out. We're going to go right after this presentation. So you'll have time to talk prior to your. All right.
Everything else is pretty good.
We'd like to save the pigs, thank you, and we walk out.
All I have to do is shot. How we gonna spend the dollars? Freaking really like these shoes. Love them.
Our next presenter are the genetic testing and counseling group. Please give them a warm welcome.
Hi, my name is David John, and the people in our group are Alex, Allison, Chloe, Grace, and Willow. Genetic testing is the sequencing of DNA to find anomalies and find diseases and disorders that present abnormalities in genes. Our group proposes that if we educate the general population on genetic testing and counseling, we will greater expand the knowledge of humans through using resources such as counselors, websites, and brochures. Many people have a misunderstanding of genetic testing and that it doesn't bring many benefits. But since the 1900s, many diseases have been discovered along with tests that help doctors analyze if they have such a disease or not. The more time we devote to genetic testing, the better off it will be in the future.
The Centers for Medicare and Medicaid Services, the Federal Trade Commission, and Food and Drug Services, Food and Drug Administration, I'm sorry, work to set new requirements for the proficiency of testing, to prevent false advertising in genetic testing, and to regulate the actual test kits. The Human Genome Project, which was arguably the most significant study in genetics history, was completed in 2003. These studies successfully mapped the entire human genome, which can be used for comparison in genetic testing. In the past few decades, genetic testing has become an integral aspect of healthcare, but most people do not play an active role in their care. This didn't seem like such an issue until people began losing their insurance or even their employment as a result of their test results. Patients who fail to advocate for themselves are not reaping the full benefits of genetic testing, and many are even being harmed by their results. So we decided that the biggest issue in genetic testing was the general public's misconception of it, and many people are unaware of the benefits of genetic testing. Those who are, that there are too many risks, it can be a valuable option for them. And what the general population thinks of genetic testing is the most important issue, because without people considering and taking part in genetic testing, it exists. And we could have addressed other issues such as cost or how much information it could find, but any plausible issue could be solved through education. And so together we came up with several options to inform the public. We thought of focusing on a specific type of genetic testing and informing potential patients of how that type may apply to them and their situation. We also thought of providing more counseling so that after testing, patients will have a smoother and easier recovery. And we also thought of providing physical resources for them, such as a website or pamphlets, so that they can have questions and concerns, such as the implication of insurance about genetic testing and research. Our group has decided to better integrate genetic counseling into the healthcare system. We've decided to employ a full-time genetic counselor at the University of Virginia Healthcare Center. And this service would be available to anyone who has received any type of genetic testing. The counselor will be there to answer any questions that the patient may have, as well as inform them of the options that they receive. The initial consultation, which will be free, and after that, patients may ask for additional services that they will pay for. We've also created a website and a pamphlet that all of the teachers now have that will provide additional information about genetic testing, as well as helping patients find a genetic counselor that will work best with them. This is a very compelling issue because people are not always fully aware of the implications of their genetics. People often make decisions that without fully understanding the consequences, and we hope that this will remedy that. So the first big step of our project is to find a local genetic counselor who would be willing to work with patients at UVA health centers. And we chose UVA because it's close by, and based on the results that we get and how people utilize services, we can determine whether we want to expand to other areas in the state or even in the country. The second big step is distributing our pamphlet, which will be available statewide. And this will be found in various health centers across the state. To gauge the success of our project, for the year of 2019, which is when we plan to start, we will have anyone who meets with the counselor complete a brief survey, which is available on our website. And this will help
help us to kind of figure out if they found it helpful and what we can do moving forward to make it more accessible and more helpful. So here you can see the breakdown of our annual budget. The biggest cost in blue there is actually employing a genetic counselor, which is about $72,000 a year. And then the second most important piece is the printing and distribution of our statewide pamphlet, which will be about $25,000 a year. We also plan to hire a part-time publicist to help us promote our project, which should be $30,000. And to go with that, we plan to hire a web developer to update and maintain our website, which should be $15,000. And then finally, to distribute our survey, that'll cost $10,000, and our total will be $152,000.
To conclude, we would like to educate people on the types of genetic testing and how it can benefit them. Many people can create misconceived ideas based on genetic testing because there's a lack of information available. We would like to reverse this negative idea by providing more resources and showing how beneficial genetic testing can be for them. In many places where genetic testing is more frequent, people often put too much trust in their doctors, and when results are communicated between patient and doctor, the patient is often left uninformed and unable to advocate for themselves. The biggest current issue surrounding genetic testing is the misconceived ideas by the public. To fix this, we would like to provide more and better resources for them to utilize. Include a genetic counselor who would assist patients at no charge, and a pamphlet that will be distributed across the state. Our group should be funded because genetic testing should be viewed as beneficial by the public, and patients who are trying genetic testing should feel welcome in their environment. Without the support of the public, genetic testing would not be able to grow and develop as it has for the past half century. Thank you.
So, are you looking at when, I guess you just make this information, like bringing the insurance costs down? So I'll tell you right now, newborn screening, or if you do pre-med, it's like $800 pop, and then your copay comes in. So, are you going to try to handle that at all, or are you just trying to inform the general public? Are you going to be talking about working with insurance companies?
So we were mainly focusing on just the educational aspect. So, and it is very expensive. But we decided that actually informing people of what is available would be more beneficial to them than trying to get it cheaper, which would be nice, but just felt like putting those resources out there for them.
Along with,
yeah.
We understand that such testing is very expensive and many people cannot afford this if it isn't absolutely necessary. So that would be one benefit, having such a counselor available to help people understand when it is necessary and when it is not, because it is very.
How long would you have your counselor available? What's your time frame?
Well, our trial period would be for a year, but we hope that this would spread throughout the country and become a fixture in any hospital.
Okay, guys, we're gonna take about a 5-minute stand-up break. You know where the restrooms are.
It's 15 minutes. The break says 15 minutes. only act locally.
I understand. Okay, Sage, wait, I have a question for you. So you want some I have one question. Okay. Are you gonna give the lab rats Parkinson's to test your thing, or are you gonna find rats with Parkinson's?
They're gonna get shot down from also, just like animals.
Yeah, well, that's why they're used it. And so. Okay, well, aren't you glad I didn't ask?
I'm not
Like, I need to ask. Because you're actually good at presenting. Like, you're not bad on the IO, and I know it.
not bad. Am I not bad or good?
You're not bad.
But am I good? Oh.
Like, you're not like.
I'm not Sage.
No, you're not. Like,
Better
Sage. You like the flow. Like, you could be that, but you're not.
They're not rehearsing them. But this one's really easy. Sorry about that.
Yeah, since all of the work, since all of the actual percentages are distributed,
Circulates the organs and sits in the organs and makes the organs non-transferable. Like,
it's all
I
of the,
know, but I all like used to be, and like I practiced and I like wrote what I wanted to say, but like
I didn't write it down. I go over it in my head like.
Yeah, most of the time, I mean, I just show up there without rehearsing,
like
just tell them what it is, because that's all you really need to do.
but like when we do have the anesthetic like together organs and of like
I'm going down as well as on.
and I'm like I can't because they have less than 24 hours. So they would have to anesthetize the animal. What would happen to like
Live. It is live. That was recording us too. What it is. Whoa. Look at my hair. Who is watching it?
yeah, so like
I don't think we should break the fourth wall. Stop talking about it.
I don't think my first
It's like we already just covered government program,
Brainwashing us.
you know, to get like the best possible people. Maybe it's like
Maybe what they do is
it's like a maze runner, and they're trying to get like really smart kids together to try to like freaking put us in a giant deadly maze to I don't know where I'm going.
Let me get a
One.
one deadly maze.
he ran away.
Every time somebody's like, and then it's like anything. It's like, let me get a one predator missile strike. You get down jump like, let me get a 59 tomahawk missile. Let me get a. Let me get a big back. Wow, look at those junction mandibles. Mandibles is like a mouth. Yeah. It's like ant mouths, right?
Otherwise, so when they brought that up, whichever people brought up this pill bottle had the blue pill liquid, they had this like, they didn't know how.
Spiders have them?
We're gonna strengthen immune
I think so.
Yeah. Yeah, it's like little mouth arms.
They're trying to young
It's so funny watching it grab you.
Yeah, they're like,
It's like it's just like
except they're just like,
how many people get sick?
it was hilarious on your story. I kept thinking got to see one of those crabs with like crazy eyes. And, like,
yeah, they're like, I was like free Eugene. And you were like touching it, and you just didn't even care.
I feel like if they would have expressed it, I feel like if they would have answered the questions done for the research into what immunosuppressants are, because when I asked them, they just straight up said,
It was so funny. It was just like sitting on the beach, and I was like,
I thought the
boy.
presentation was great, but I don't.
It was like sticking halfway out of his hole. And so the guy was with like got the stick and like put it under his front legs and like dragged him out. And then I got him to like hang on the stick. And then I put him on a dead fish. So he probably ate that.
Wow, that sounds so weird.
So we are 3 away. Wait. Is it just gene therapy or genetic testing? We're behind schedule right now. I'll promise. 10:35 and 10:34 and 10:42. I'm gonna sue. Nice. You say except for
Gene therapy.
I need
Yellow. I am.
All right, please welcome the gene therapy group.
I want you all to think about your family. Some of you may have inherited blue eyes, curly hair, or perhaps you're a carrier for a deadly disease. A study by the World Health Organization concluded that the top cause of death in 2015 was ischemic heart disease, as well as diabetes and strokes may be linked to genetics. How common are genetic diseases? The global prevalence of all single gene diseases at birth is approximately 1 out of 100. This is an issue because fatal genetic disease such as cystic fibrosis, Huntington's disease, and Tay-Sachs have become more prevalent. The average survival age for those with cystic fibrosis is 40. Those with Huntington's disease die 10 to 30 years after developing the disease. Children with Tay-Sachs die by the time they are 5. We can fix this with gene therapy, a process in which cells with faulty genes are replaced. Germline gene therapy is the insertion of therapeutic genes into reproductive cells. So babies are born without mutation, and they will pass down their healthy cells throughout generations. With germline gene therapy, we eradicate all genetic diseases and disorders in the future. Germline gene therapy has tremendous potential, which is why we must fund for further research.
Some people see it as patient privacy. Some see it as a way of playing God. Others see it as a form of defense. Because of this, the government and multiple research institutes have created programs in order to take care of those ethical issues. by NIH in 1974 response to public concerns or ethical legal issues in doing. Today they act as an open public forum for discussion on these issues. They also review any human gene therapy tests. Center for Biologic Evaluation and Research, or CPR, was created by the Food and Drug Administration to regulate the therapy. All products must be tested to meet CDCR, and their intentions must be told to see if they are safe enough for testing. And CBER first test in laboratories, then in larger environments.
Ethics is one of the following. Ethics is one of the issues that has to do with germline gene therapy, and we believe that the ethical aspects of this process should be looked at more because they because some people may believe that it is essentially like playing God, and since it is adding in desirable traits or inserting traits in place of another, but it can actually be used in a beneficial way to help prevent future generations from being born with fatal genetic. Research is also another issue that has to do with germline gene therapy. And we believe that research should be looked at more because there isn't a lot of research being done as of right now on germline gene therapy, and we don't exactly know the long-term effects of it as well. And so the more research that is being done and tested as well could lead to germline gene therapy being both easier and more accessible, meaning that we could, future tests would lead to us finding out the long-term effects, what they are, and whether they are beneficial or detrimental and how to fix them, as well as how trying to find another way of inserting the gene into the cell, which could possibly be a more expensive way, which would then lead to this process being more affordable to people. And some of the actions that we can take to address these issues would be to raise awareness by advertising for what exactly germline gene therapy is and what it's all about, as well as advertising for funding research.
Instead of creating an innovative way to perform germline gene therapy, we decided it was important we decided that we should fund the National Academies of Sciences and Medicine further this study. We think it is important because there are many rumored side effects that could take place during this procedure. We need to make sure we understand all the possible outcomes to ensure public safety. In addition to, we will create a website that will asking for support from other organizations that will increase funding. We are creating a stepping stone that has not yet been created to bring us closer to the cure of genetic diseases and allowing access to them.
Our budget will cover a 3-year plan of specific actions to be completed within the year 2020. First year, we will work with a business plan consultant in order to discuss the potential benefits and revenue associated with our partnership with our 2 organizations of choice, NAM and NAS. Once this partnership is established, this will allow us to support their funding needs. Now, how are we going to do this? Through advertisement. Advertisement via social media, television. We're also going to have our own marketing strategy and our own website to take in donations. The advertisement is key because it allows us to have a foundation to where we can promote positive aspects of gene therapy that's being executed by 2 organizations. Any other cost in the first year will be geared towards creating and administering medical surveys for those who potentially become volunteers for clinical trials held by the 2 organizations. Now, over here, you're going to see a breakdown of all the actions that are going to take place. this process, and you're gonna see cost per year, the first year, and you're gonna see the second, third, the second part, which actually you have to multiply that by 2, and then you're gonna see the grand total, which is $172,420.
Our plan, as I said, is to collaborate with national academies of science and medicine, or the NIS and NAM. They're a group working on furthering the research of editing the genome. Our work with them will start with us reaching out to them after we receive the grant money. We'll also be working semi-independently to spread awareness of their our semi-independent work will be done through various advertising methods, such as through social media outlets, TV programs, or through the news and our website. The success of our funding will be seen as the public eye begins to widen the success of germline gene therapy, and as more and more research and clinical trials are done in this ever-growing study.
Gene therapy has the potential of being the last form of therapy that the race will have. So that's why we need drug money in order for NAS and NAM to do further research so more trials can be held. That way, we can save more lives. Thank you.
Alright. I'm just trying to follow some of the local law. Where are you getting $44,000 for the advertising? So far, are you talking about running that fee or like a pay? My impression would be actually hiring a marketing agency or creating your own marketing.
So we're hiring a marketing agency, and then we're going through like locally. Because if we were to have it on a national basis, in order to run a commercial or an ad on TV, if it was nationally, it would be over $340,000, and then an additional $100,000 every time we were to run it all together.
And did you actually get those numbers, or you just guessed?
We actually got those numbers through sites such as Executionist and SurveyMonkey.
I'm sorry, through what site?
Executionist and SurveyMonkey. And that's also a typo right there. That's supposed to be $19 instead of 19.
That clarifies. And the other one that I'm asking is, you gave a grand total of, do you remember?
$172,000, $420.
Question over here.
You said you were gonna fund someone else to do these things. Why don't those people invest the money themselves? On one of your slides, you said you were gonna fund someone in the research. What if those people decide to fund it themselves?
I think if you go back to your objective page, I think this comment is that you were in partnership, not necessarily funding. Am I correct in what you're, I heard the same thing, but you're in partnership with the National Academy of Science. Now, I think your question asks again, why don't you, I think he's asking, why don't you just fund them to let them do your work? I think, I'm not one to put words in your mouth.
The main problem with just doing the research on our own is that it would cost too much money to get the equipment from scratch. So genetic modification equipment is very expensive. With just the $250,000, we wouldn't be able to get nearly all of that we need. So partnership would be much more beneficial to both us and them for cost and research efficiency.
So,
Hold on, think about your question.
okay,
Okay.
You said the government is taking. Are they in favor of? people in general are the ones who think that it is like playing God. So it's not that the government has anything to do with that.
All right, so you want my money for research on germline gene therapy and for advertising, or you want my money for the advertising? Because where's my money going?
The money would be geared towards advertisement, so that they could do more research, because we're not.
Who's they?
The two associations, NAS and NAM.
So your role, you're proposing is that you would just create an opportunity for a business plan, a person to do this marketing and TV advertising. Who would create the advert? Where would that come from? Is that coming from this 44,000 to, is the 44,200 for actually running the ad?
We're actually getting that up and running, yes.
Okay, and it only costs $1,500 to actually produce the ad?
Yeah.
You don't have to pay anybody to give information about what you're including here?
44,000 is the one to get it all put together, like the actual itself, the ad. Is in addition to the 1,500 for it to play.
So is that a one-shot deal? It plays for 30 seconds and you pay $1,500? Right. And you're only going to show it once?
So that's 3 years. And through that would be like once that was added.
Very good, thank you.
It's so simple. Mostly hiring workers. Like,
please welcome the group that will be presenting the performance enhancing drugs.
So, good morning. My name is Austin. This is Carla, Liam, Jordan, and dang it, Adora. We'll be talking about performance-enhancing drugs. And performance-enhancing drugs have been around since the very first Olympics, and they're still used today. And it's a big problem because it pretty much, they use it because it gives a nice boost that gets you above the average people who aren't using them. And it's a really clear advantage. And the main reason that everybody doesn't use them is because it brings down a negative side effect to your body that can actually really hurt you and cause death. And the main purpose of our proposal is to try to create a drug that will make it less side effects and make it healthier for you to take it, so everybody can take it and it'll be an even playing field for everyone.
There have been many debates regarding performance enhancing drugs. Some people say they need to be legalized, and others say that there should be more regulation. So many people do know that they are negative, but choose to look the other way just to see their team win. There have been many organizations, associations, agencies created to try to put an end to the use of performance enhancing drugs in sports, but every sport sort of has their own rules, and sometimes they can be really lenient or they can be really strict. The World Anti-Doping Agency has some rules, but they're not really the same for every sport. That being said, there are some consequences. Some athletes can be suspended from games or even kicked out of that sport.
So how can performance-enhancing drugs affect the human body? Recent research indicates that there are numerous health effects that cause concern among athletes. These effects can include heart disease, liver disease, infertility, muscle damage, and even neurological issues. According to a recent study, individuals who use performance-enhancing drugs, or particularly anabolic steroids, had significantly decreased gray matter than those who did not use steroids. It was also found that performance-enhancing drugs can cause behavioral changes as well. There are also many cardiovascular concerns with performance-enhancing drugs. These can include hypertension, infarction, stroke, and even cardiac arrest. It has been concluded from this that there's a 12.9% mortality rate from stroke and other cardiac malfunction among steroid users, compared to a 3.9% mortality rate of non-users. That makes steroid users 4 times more likely to die from a cardiac malfunction. With these health concerns, it's hard to ignore this issue, and that's why action needs to take place.
So what are we doing? Our goal is to create a safer alternative to anabolic steroids or performance-enhancing drugs that people can use in place and not suffer the harmful side effects. Right now, anabolic steroids are Schedule 3 drugs with the FDA, which means they have a slight potential for abuse, and you can only get access with a prescription. What we want to do is get it scheduled lower so that it's more accessible and primarily make them safer. That way, we hope that the performance-enhancing drug problem will solve itself as users go and try to get our new drug instead of using the harmful, outdated anabolic steroids.
We would like to have our research done in 5 years. With working with the World Anti-Doping Agency, we want to do our experiment in a lab at the University of Pennsylvania. Our experiment will consist of 3 groups: the control group, people that don't use any steroids or performance-enhancing drugs, a group that did the substitute of Colgate, and another group that uses the regular performance-enhancing drugs. We will measure the results by taking the vital signs of all the people that are part of the experiment, and then seeing the effect that the new drug will have on them. We are asking for $472,000 as to get this experiment and drug on the market. The money will be used for the lab, the researchers, getting our experiment out into the public, and letting everyone know what we're doing.
So in conclusion, our research is going to go towards finding a safer alternative to the current performance standards, and just make it safer for those who use it. And this research will be conducted at the University of Pennsylvania. Any extra money that is not provided by the grant, we think we will get from the World Anti-Doping Agency, the WADA. And this research is very important because it can help save many people who are hooked on performance-enhancing drugs and even playing field in sports.
I just want to make sure I understand. You don't have no issue with them taking performance enhanced drugs. What you are trying to do is, if you're going to do it, you're trying to give them a safer drug.
Yeah, we think it's unrealistic to like completely like stop the circulation of performance-enhancing drugs in public. So we're just trying to make a safer.
So with making your safer alternative more accessible, do you have any concerns as to people who don't want to use the drug having an advantage because everyone else is using it now?
There is a problem with that, but it is up to them. And like nowadays, people still use steroids and everything, and they don't get caught. It gives them an advantage anyways. So this is a better way to get them to everybody to be safe. So if you wanted to, you can take it.
Okay, so you're geared towards athletes, right?
Yes.
Did you ever consider going towards the public with this?
Eventually, maybe if we could get it out to where it's extremely safe and it wouldn't cause like an addiction or anything like that for a negative side effect.
So correct me if I'm wrong, but the anti-doping agency is against the use of steroids in athletics, right?
They are against it just in general, but the reason they're against it is that it causes all these side effects to hurt them and everything like that. So if we were to come up with a drug that wouldn't hurt them as much or help them, because people are addicted to this and they can't get off of it. And so giving the safer drug to it might cause.
So to piggyback on that question, mine is, yeah, you're doing great. You are doing great. So WADA, the anti-doping, World Anti-Doping Agency, what have you found in the research as far as funding that they have given to research either a new acceptable dope for their athletes? I don't know what else to call it. Because I'm assuming you're talking about it being in some sort of pill form, correct? Even though, as you shared earlier on, that there's all sorts of doping techniques. So what do you know from WADA as far as, do you have any information there?
Okay, so the person that we researched, Lana, the logistics slide, speaker, and she actually had all the information, all that.
Can I get my one in real quick and keep it really, really short, but I want one clarification. How much you asking for? I saw nothing whatsoever, and there's no money sent out there. How much are you asking us for?
470.
I'm just making sure, I'm clarifying. I didn't hear that as that was presented. You did,
Yeah.
it wasn't on your slides anywhere. That was your total amount. So I.
But that, we didn't get a breakdown, we just got a.
Couple more.
So would you be hoping that athletic, like professional athletic organizations would like make this acceptable, or would hoping that athletes who prefer to use steroids illegally would use them as
Well, I guess like the main thing is, like speaking like legally, like like most steroids, are already like illegal. And, but see, so there's like really no like efficient way to completely get them out of circulation. So if like people are going to use them, they might, it would be better to have a safer alternative so that, they're not going to die.
So you mentioned how steroids can be very dangerous and even cause death. How do you plan on testing that new steroids without knowing their new side effects?
Well, we plan on having a survey, like making sure that like the ones who do use it, like take the survey so we can get the results and
For the first trials that we're trying to go for is try to use it on animals for a kind of see how it reacts to their body. And then afterwards, we'll go to human trials and then test it from there.
I know there's lots of questions, but we got to keep moving on. You guys done a great job. Thank you.
Bailey, you're gonna say. I'll look at it. John, you're gonna say.
Nah, you guys aren't good.
I know one half was Savannah, I think the other one is.
Excuse me.
Madison.
Name.
So it wasn't, I think it was Nelson.
All the activities. I said they were done. Looks good. Oh, we have another.
Good job.
Very good. Please welcome the antibiotic resistance group.
Hi everyone, my name is Elisa, Brianna, Taylor, Molly, and Cyrus, and we're here to present our proposal for antibiotic resistance. Antibiotic resistance is the ability of bacteria to resist any type of antibiotic treatment. This has become an issue in recent years as it decreases the effects of antibiotics on bacteria. The more antibiotics that have resistance built up against them, the more new or altered antibiotics must be created in order to combat the lack of effect. This creates an issue if the new antibiotics are then overused, which then causes them to have a resistance built up against them. The most obvious current need is more information on resistant bacteria and how to combat treatments that are not effective on bacteria. The end goal is to create a new antibiotic that is stronger and more effective, able to treat resistant bacteria. However, the process of creating an antibiotic requires extensive funds, time, and resources. Therefore, our proposal is to start with the basics, a small research lab with a few part-time workers, in order to start the endeavor of creating a new antibiotic.
Antibiotic resistance is still a major problem in modern society. In America alone, each year approximately 2 million people become infected with these pathogens, and over 23,000 of those cases result in death. Many various medical organizations have made attempts to combat these pathogens. The CDC, a federal health organization, has recommended that these organizations collaborate and narrow their efforts to 4 main goals, which are to prevent the spread of pathogens, strengthen surveillance, identify pathogens, and further research. First, the CDC recommends that health providers are better educated on the proper administration of antibiotics, as improper administration is a large factor of the spreading of affected bacteria. Second, the CDC recommends that communication between healthcare centers is improved so that they can better respond to outbreaks and figure out how to combat them faster. Third, the CDC is working to improve medical testing to identify pathogens that have appeared faster. And finally, the primary goal of the CDC is to conduct further research and improve it and collaborate research that has been conducted worldwide in order to find a way to combat it. Current research has been very successful. Recently, a MCR1 gene was discovered, which is responsible for the bacteria's resistance to the antibiotics. So being able to manipulate this gene or even remove it could provide a cure for that. And this shows how well research so far has been promising. Further research is required.
So escape pathogens are the 6 most deadly multi-drug resistant bacteria that are mostly located in hospitals. These are also most commonly known as HAI, which AIs. They're hospital-induced infections. The main cause of this is that the pathogens develop resistance much faster than the novel drugs are being developed.
Because antibiotic resistance is a serious and growing issue, action must be taken as soon as possible. The ultimate goal is to create newer antibiotics to combat this resistance, specifically in the escape pathogens. However, this will take over a decade and cost millions of dollars. Therefore, with a mere 250 grants, this is not yet an attainable goal. Research must be done on a smaller scale first. While we want to make the new antibiotics, this smaller scale research must be done as preliminary work. This research will be done smaller scale laboratories similar to those at the University of Virginia. These laboratories contain a great deal of counter space and equipment within a relatively small space. While this research will not be creating the antibiotics themselves, it must be done. With the great threat of the superbugs, infections that are resistant to all known antibiotics, this research must be done. Researchers need to know more about how the infections are spreading, which is why this preliminary work must be done. They also need to know more about how the escape pathogens thrive and how antibiotics can be altered or improved. Only then will they be able to work towards creating newer antibiotics to combat this resistance and fight off the escape pathogens.
Our budget and logistics for what we're really doing is fairly simple. We're asking for $250,000 set to hire 5 part-time researchers, and hopefully we'll be able to put them in a lab somewhere like UVA where they have equipment that we can use and space for us. We got these 5 part-time researchers because at year's end, they will collectively have put in 6,500 research hours, which is more than sufficient to do what we will be doing, which is just very basic research towards producing a new antibiotic that can these very resistant escape pathogens. Now, at year's end, we will definitely not have an antibiotic that we can roll out to the public. So we will be giving our research, our REO, some pharmaceutical corporation or government agency that can take our research to the final steps and get it FDA approved, get it so people can use these antibiotics and actually help people with these.
The end goal is to create the ultimate antibiotic that can combat any bacteria that is treatment. With this preliminary research, we plan to just take the first steps into this long process. And setting up a small research lab is the perfect way to kick off this process. And will hopefully open new doors of information to the antibiotic world. As this research develops and new ideas and discoveries are published, the project should gain attention and funding that will hopefully lead to the initiation of clinical trials. This research is extremely important not only today, but for future generations as well. The preliminary work we're planning is crucial to the development of new antibiotics. If more research is not done, then bacteria will continue to gain resistance, and eventually all strains will be resistant to any type of treatment. The need for this information is continuously growing, and in order to protect future generations, more research must be initiated as soon as possible.
So, first of all, thank you for acknowledging that science isn't always about the product, but that process is really important. Not jump ahead of ourselves. Thank you for that. So, my understanding is you want this 250K to do just preliminary research. Let me clarify one thing before I ask. When you say escape pathogens, what do you mean by escape pathogens?
So it pretty much stands for like the scientific use of pathogens that cause MRSA, pneumonia, and urinary respiratory tract.
These are the ones that are resistant to the current
Yes,
antibiotics.
they are the escape survey. They are the most like the least bad.
Okay. All right. So you got your preliminary research is how do these escape pathogens function? How do they work? We need more information about that, correct? And we also want more information, and correct me if I'm wrong, but the other place that your preliminary research is, what do we know about how our current antibiotics work so that we might be able to tweak them or modify them or change them, create a new antibiotic? That's all you're looking for. You're not looking for anything wouldn't move towards right away, right?
Since what we would be doing is actual research towards solving this problem, if we don't want our research to just essentially go away, we have to give it to someone who can do this so they can actually, because making an antibiotic costs an average of $359 million.
Right.
It takes 12 years.
Right.
So we're planning on giving our research to like some bigger body that could finish that they actually get it also they
Got it. Thank you.
Would you want to give?
Yeah, we had some debate about whether to give or sell this.
And I'm just making sure everyone hears this, as a donator of money, even if it is, and I'm gonna go back to, I'm Bill Gates, I'm donating money, are you gonna give that away? And some people are, what's your cause? Are you trying to be able to perpetuate that? That's why I'm just saying give is, you're just saying, we're gonna take up 250 and the research is gonna give. So, good, and I like to do that. Good.
So is there, again, any concerns that if you create a more powerful antibiotic that bacteria will just evolve or mutate to avoid that as well and then make them harder?
Well, bacteria and other things are constantly changing. So again, in the future, there will probably again be resistant bacteria to what we hope to produce, because this is an almost unsolvable problem. But if we don't take the steps that we can right now to stop where the problem is, it's going to be going to blow up. We're not going to be able to stop it. Period.
She got my question. Sorry about
Thank you very much.
Yeah. Budget check. I think. I do. What? No, we are. I did.
All right. Well, yeah.
Oh, no phone.
So halfway through, and she said that, I was like, oh, let me just change everything real quickly so I can have that in there. Oh.
Wait, did you just whip in A? Oh.
All right, please welcome our last presentation before lunch, human life extension.
Hi, I'm Bailey, and this is John, Grayson, Olivia, David, and Tyrone. And our proposal is for human life extension through bone marrow transplant. Bone marrow transplants are conducted in humans today to cure diseases. A bone marrow transplant is when bone marrow is extracted from the bones of a healthy donor and put into the bones of someone with, say, an autoimmune disease or a blood disease or something like that. And bone marrow transplant gives the patient who receives the bone marrow healthy stem cells that do not have a disease, which can multiply and help treat them for many different things. Bone marrow transplants they can, in today, they are used from a genetic match donor in humans, but the possibilities for life extension
could be used with the donor being the patient themselves. When they are young, they extract their bone marrow, and then at a later age, they put it back into their body after it has been cryogenically preserved, and this would help prevent effects of aging as a disease. So we are asking for $400,000 to provide research into bone marrow transplants for the purpose of life.
The first example of this method, as far as expanding lifespan of an organism, come in a Moscow study funded by the National Center for Biotechnology. In this study, mice were experimented on. There were donor mice, test mice, and control mice. Donor mice had bone marrow extracted from them at an early age, and this bone marrow was then cryopreserved until the test mice were of a certain, or at a certain point in their lifespan. The bone marrow from the donor mice at an early age was then inserted into the test mice. Test mice were measured against the control mice as far as their life from that point. And in the experiment, the results were that the test mice were able to outlive the control mice at a lifespan about 34% longer than that of control mice that did not have any tampering with it. While this experiment did consist of donor mice, it's still arguable that with rather than genetically similar mice and genetically exact mice, lifespan could be increased greater, more than with genetically similar.
As with any upcoming technology, there are always problems. The problem we decided to focus on was the lack of funding for research using bone marrow to extend lives. To basically negate this problem, we decided to use all of our funding, all of our grant money to fund the research for bone marrow. As of now, there is promise in bone marrow transplants to extend life based on a Moscow study at the Russian Academy of Sciences and the Russian Academy of Medical Sciences. The experiment proved that they experimented with mice and determined roughly a 34% increase in lifespan when they tested on mice. To add to this, bone marrow transplantation is also possible in humans. We just need to give researchers the funding to put these both together and make it so that bone marrow transplantations can occur to extend life in humans.
Our proposal is to have a research lab where researchers can conduct more experiments with bone marrow transplantations in humans to extend human life. We would need 1 research lab and 2 full-time researchers and 1 part-time researcher. These researchers would focus on perfecting the process of bone marrow transplantations in humans, and hopefully just doing more research to perfect this so that they can conduct more successful bone marrow transplantations. The original startup cost for 1 year would be $265,000. However, considering future needs of this research, our total would be $400,000 to cover many years of research in bone marrow transplantations in humans.
Programs such as Calico, which is funded by Google, are the future of life extension. With big money companies funding their research, these programs have a much higher budget compared to those of, let's say, universities or any other group. So, in a sense, companies who are funding research for human life extension are attempting to take a monopoly or control a monopoly. They want to take every aspect of it in control. Several aspects include what is done with the research, when somebody's research, what costs the procedure, and etc. Now, also, civil sciences in Moscow, as mentioned before, have done an experiment with mice. And in this experiment, the scientists concluded that the process of bone marrow transplantation is the process of transplantation of genetically identical lower genetic errors. Now, what that means is this, in humans, have stem cells extracted at a young age. At that young age, they wait a while until an older age. When it's at an age, they do a autologous transplantation, which then allows them for their stem cells to mutate. So, now, all for future research and more experiments, scientists can use this experiment as background information for future breakthroughs in this subject. Such as an increase, such as from 34% of mice expanding mice, we will be able to go to say about 50% within several years. Bone marrow transplantation. These is like stem cells that create all these different types of these types of blood cells that create this bone marrow. Such as red blood cells, blood cells, and platelets. One of the stem cells leads to so further knowledge mature knowledge on bone marrow transplantation and extending life. We use evidence gathered from the mice experiment on that bone marrow transplantation is, as it already showed, is cool. These experiments done but there was more recent time on this subject to can more efficiently get analysis.
Oh man, I forgot mine.
I don't know if I just missed it, but what does bone marrow actually do in your body?
So bone marrow contains stem cells, which are unspecialized cells that are like young and healthy. They can be made into any type of blood cell, as Tyron said. So when you transplant them from the bone marrow, it gives you healthier stem cells make blood cells. So it gives you healthier stem cells, which would make your blood healthier and could prevent.
Has that like child bone marrow extraction and then put into an adult ever happened?
No, not as of yet. That is why we will be trying the research. That's why we cited the mouse study, and we believe that it could be very effective.
Sure.
So would your research mention testing implications? Would you test it on?
As of right now, as we were talking about, it was originally done on mice. And that's a very small animal, not very unique organism. Now we would do something like our process for our first trials, maybe get a larger animal of some sort, or something that has similar identity as the human. And when we use that, and the results gathered in that, we would then move on to trials.
You connect the bone marrow to
As the cells in the organism usually tend to have more errors and complications as life goes on. The goal that we're aiming at here is inserting new bone marrow that has not yet been aged into an organism, and thus causing less complications that we down the road and causing it to live longer.
So as an organism ages, when a cell divides, the telomeres on the end of the cell's DNA unwind, and means the ends that are unwound from the DNA don't copy. So every time the cell divides, you have more possibility for genetic error, which is why people die as they get older or get more diseases. So that's why we are looking at stem cells in the bone marrow, because they can specialize into blood cells that would not have diseases or be older yet.
And that's exactly why we plan on taking stem cells at a younger age, meaning when they're premature, later on throughout the life. Let's say when they're about 60 or 70, when they start realizing they don't know how much time they have, transplant that new stem cells that have not aged throughout the period of time into them, and they have rejuvenated cells.
talking about injecting their saved. So I'm born at a certain age, stem cells are cryo frozen, and then just before my 56th birthday, as my bones start aching, I get an injection, and I'm going to have less unraveling of glands, less. That's the only way you're going to get the injection. That's actually removable.
I believe it, yeah. We haven't exactly determined the exact way of removing our bone marrow, but
Bone marrow is very.
it's
That's why we would be suspecting it. It's actually kind of similar to blood. Sometimes people will, give blood, but if they are a certain blood type, they'll preserve it for themselves at a later age. That's basically what we're doing, except we're doing it with bone marrow that would, help extend human life. It's very similar to blood.
very relevant. It's not like, okay, the misconception is that this is a sci-fi topic, meaning that in a lot of movies and et cetera, there's been things where it's been a lot of misconception where we prolong our life to like you live to 200 years old. Well, that's not what we're trying to do. All we want to do is increase life cycle, like meaning all we look forward to is increase life cycle to a short period of time, about 50 years. So maybe over a course of about 5 years, we expect to have a minimum of somewhat about a 50-year life expansion. Do you know if there's any negative effects of taking bone marrow out of somebody?
It could cause pain, but other than that, I don't think there are any.
Sometimes infection of the site.
Sometimes
You're
there's
susceptible to infection.
But it's a relatively normal procedure as of now. They use bone marrow transplant to cure diseases and such all the time.
So, once you transplant the bone marrow and extend their life for 50 years, their organs, wouldn't they start to fail as soon as they hit a certain age anyway? So would it be worth extending their life for that long?
Well, the organs are made of cells. So if you insert the blood and it's healthy, then they're less likely to get a disease and their cells would be healthier, which would in turn make their organs be healthier, which is why it's a possibility to extend.
But like blood cells are different than like, say, a brain cell.
Well,
These don't produce brain cells. What?
Well, blood goes to the brain. And blood.
Yeah, but the cells in the brain would still die, right?
No, because there are many different ways to extend human life. Bone marrow transplants are just one way to do it. So if you did end up extending your life through bone marrow transplant, you would also need other techniques for other parts of your body, like organs failing. You would have to have other remedies for that.
So this is just like a blood cleaner, like a long-term blood cleaner. Yeah.
Very good, guys. All right, go ahead and take a minute here to
I had to ask you a question just so you could respond, because you did that really on Yeah, I remember. Yeah, you shout out to me on Rome, and I shout out to you on. I know.